Hi guys, today we're going to be looking at applications of the Pythagorean theorem using radicals. So one very common thing that you're going to see over and over is questions asking you to apply the Pythagorean theorem and to find the exact, let me just switch pens, okay, to find the exact length of a side of the triangle. So if you think back to when we were doing like review problems with circumference or area of a circle, exact in those situations meant in terms of pi, because pi is an irrational number, and if you try to use its value, you end up having to round. And so by rounding, it's not exact. In this situation, you're using radicals, right? And those are, if the number under the square root is not a perfect square, it represents also another type of irrational number. And you're going to end up in the same situation as you did with the circles, where you're going to have, if you try to use the decimal value, you're going to have to round the decimal, therefore making it not exact. So in questions that involve radicals, when they say, like if you look at example 1, find the exact length of a particular side, that's going to mean that you need to express your answer in simplest radical form. So they won't say explicitly simplest radical form, they'll say find the exact length. And so if it involves an irrational number in the form of a radical, that means that you simplify your radical. So example 1, for instance, says the hypotenuse of a right triangle is 3 radicals 6 inches long and one leg is 6 inches long. Find the exact length of the other leg. So they're describing a right triangle that looks like this. The hypotenuse measures 3 radicals 6 and one leg measures 6. You need to find x. So you apply Pythagorean theorem, a squared plus b squared equals c squared, and x squared plus 6 squared equals, and make sure you have parentheses because we are squaring the whole thing. We are squaring the 3 and the radical 6. So I have x squared plus 36 equals, and you can do this in your head or you can write out little steps, but 3 squared is 9 and square root of 6 squared is 6. So you could definitely do that in your head and just get 54. X squared plus 36 equals 54. Subtract the 36 over. I have x squared equals 28. And now I want to take the square root on both sides, right? So I'm going to have x equals square root of 28, but I don't leave it like that. I want simplest radical form. 28 is 4 times 7. Square root of 4 is 2. So this will be x equals 2 radical 7. That's simplest radical form. And that's exact, right? Because it hasn't been rounded. If I put the square root of 7 in my calculator, I'm going to get this really long irrational decimal, which would then have to be rounded, and then it would not be exact. Okay. You know what? Looking back at my math, hold on. No. I think I forgot to, yeah. Okay, so this should be a 1. Let me do it in red. It's the same concept, but this should be 18. And that should be 18. And so this is going to be 9 times 2. So this would be square root of 9 is 3. So this should be 3 radical 2. Okay. Same concept. Another type of question is where they give you 3 measurements of a right triangle, and they ask you, is it a right triangle? So they're telling you that the measurements are, this would be A, this would be C, B, and this would be C. And the way I can identify C is that C is the longest side. And if it in fact is a right triangle, then it will satisfy the Pythagorean theorem. So what you do is you plug all values into the Pythagorean theorem. If it makes it true, yes, it's a right triangle. If it doesn't make it a true statement, then no, it's not a right triangle. Then it's just some other random triangle, like an obtuse triangle or an acute triangle. So we have, we're going to square 5 radical 2. You need parentheses. Squared plus parentheses 3 radical 5 squared. Does that equal 10 squared? So when I square 5 radical 2, I get 25 times 2, which is 50, plus here I get 9 times 5, which is 45, equals 100, and this does not equal 100, so no, it is not a right triangle. Okay, and the last example I'm going to do with you guys is actually just a really simple word problem from 8th grade, but I just wanted to go over it with you guys in terms of like how you would label your diagram. So if you draw a diagram of the situation, a 24-foot ladder rests against the side of a house. So you have a house, which is vertical, that's your house, and you have a ladder. A ladder is like this. It leans against a vertical surface, and there's your right angle. So a 24-foot ladder rests against the side of a house. So the 24 is the hypotenuse. If the foot of the ladder is 15 feet from the base of the house, so the foot of the ladder is the bottom of the ladder, is 15 feet from the base of the house. They're describing this base here of 15. How high up the house does the ladder reach? So they're asking you for the vertical distance. How high up does the ladder reach to the highest point that it reaches on the house? Okay, so sometimes labeling these diagrams with the wording can be a little tricky, so I figured I'd go over it. And so this is a really simple x squared plus 15 squared equals 24 squared. This doesn't involve any radicals because they are asking me to round to the nearest tenth of a foot. So just be aware that if it says to round, then you're not exact and you're not in simplest radical form. You're going to use your calculator and you're going to round it. So I have 24 squared is, 24 squared is 576, and 15 squared is 225, and I'm going to subtract. I'm going to get x squared equals 576 minus 225 is 351. I'm going to take the square root on both sides. X equals, and the square root of 351 is 18.73. It says to the nearest tenth, so it'll be 18.7 feet. Okay, and then today we'll work on some of these in class, and the next section we'll do tomorrow. All right, thanks.